Hello and welcome back to the Reapers. Today we're in our brand new Polycarbov I-16 Ishak. We've got Star with us and we're just trying to figure it out. We think we've got the cockpit pretty much figured out. If you are watching this and you've got this aircraft, then you'll probably realise there's pretty much no manual for this yet. Or there is a manual, but it's pretty much a different version of the plane and nothing matches up with what it says in the cockpit. So we're just going to have to figure it out with deductive logic. Before we go and look at the cockpit, let's just have a quick look around the outside. It's obviously an awesome looking plane. Weird, ugly, awkward, socially inept, basically just like Cap. And it's just going to be pretty much my perfect plane. You'll notice it doesn't have a closed cockpit, so it's open. You notice it's got a thumping great radial engine. That's sugar, is it not? M63 or an R63, I forget now. It's a 30-litre... a 9-cylinder engine, so that means what each cylinder, which you can see in there, is over 3 litres, which I don't know any other engines in the world that are that big cylinders. So it's crazy engineering going on there. You can see.
I think the sound was pretty close actually. It was like 18-cylinder, 46 litres odd.
Roger. Either way, that's big engineering. I mean, it's interesting history. It was the first version in service was 1933. And I mean, I haven't researched this thoroughly, but I understand it was used for about 10 years, all the way up to World War Barbarossa, wasn't it? Do you know about that?
Yeah, I mean, the Russian Air Force was not particularly well prepared to getting attacked by Germany in the first place. So they didn't really have that many modern aircraft, and in the beginning also they just got wrecked on the ground a lot.
Roger, this is a relatively late version, so we've got a pretty high power. We've got wartime emergency power of 1100 horsepower, normal continuous horsepower of just over 900. So I don't know what year this model was in, unfortunately. So, but I'm going to have to assume it was contemporary with the you know, kind of the World War II fighters, you know, 1940 onwards. I stand to be corrected as ever.
Well, I think it's more 1930s fighter. I'm not technically sure about this specific version, but you know, they were used in the Spanish Civil War and such.
Roger.
So it's like early BF-109s, AG-112, stuff like that.
Roger. Speed is about 300 miles an hour, so it's well behind its contemporaries in terms of early Messerschmitts and stuff like that. And as you can see, it's obviously not very streamlined.
Are you sure that's miles an hour?
Let me check the manual. So we've just done that again. It looks like 287 miles per hour maximum at its optimal speed altitude. So that's behind its contemporaries, and you can see it's just not particularly aerodynamic looking. I also notice it's a 2-blade screw on it, which I've never seen. The rest of our fighters from World War II have got 3 or 4 blades. Any idea why it's got 2 blades, Joel?
Well, I mean, the early fighters didn't have this many prop blades. If you look at other aircraft of the same era, 2 blades would be fairly typical. So the thing is, you know, if you have more blades, you also have more drag, more weight you need to drag around. The main issue is if you need more thrust at some point, you need to add blades, because if you just make the blades longer, you know, the tips of the blades always have to move faster than the inner parts, obviously. And the longer they get, the faster the tips have to move, and once you get into the area where the tips start to have to move supersonic, that's a real issue.
We've got machine guns, 4 times 7.62mm machine guns. You've got 2 on the wing, kind of, you know, just outboard of the wing roots, and 2 in the top of the engine cowling, which must be timed for the screw. Some anecdotes of this aircraft are that the top exhaust nozzles at the very top there would tend to spew out hot oil, which would jump onto the windscreen there and blind the pilot, basically. So not the best design, obviously. That's about it for the outside. I just don't know enough about it yet. We're going to do some more research at some point, but not at the moment. So let's look into the cockpit. Okay, so first of all, we can close the little door hatches, which we can go ping. That is one door hatch closed and locked. And find it, the other, can't find the thing. Ping. There is our other one closed. Okay, needless to say, this is a high fidelity aircraft, so pretty much all of the levers, knobs, buttons and everything is modelled pressable, clickable, interactive, either passively or actively. So we're going to work our way from the left of the cockpit round to the right. Okay, first let's have a look at the periphery. So we've got our gun sight here, so if we turn our battery on, we should get a look at that. So we've got our kind of holographic gun sight here. I'm not sure what these different markers mean. It doesn't say in the manual, but I'm sure they have a certain meaning. We've got here our anti-glare shield that can come up. And we've got here, if this fails, the electronic sight fails, we've got a cool little backup sight that we can do here. We align this dude in that thing there, like that. And then we pull the trigger and bang, 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 bang. In terms of rounds, in terms of rounds, we've got 7.62, 900 rounds in the wings, and 500 in the fuselage. Just get rid of that. Right, now you're going to look at the largest landing gear instrument ever seen. Star's new to this plane, so I'll talk him through it. Star, can you see around the top leading edge of the cockpit ring? You've got this big thing with degrees and stuff like that.
Yes.
Can you have a guess at what that is?
Well, it's kind of a roll indicator, isn't it?
Ha! There's another victim. No, it is the world's largest landing gear position indicator. When you, the landing gear in this thing takes basically 45% of the pilot's thinking time and ability to raise and lower the landing gear. And this, inside this tube, is actually a spring. And this spring is showing the position of the landing gear, currently kind of in the upper position, so the up and locked position, or down, I should say, if you know what I mean. If we were then to hand crank the landing gear actually upwards into the body of the aircraft, this was the first Russian plane, by the way, to have retractable and fully sealable landing gear, then this spring, left and right, will go all the way down to the 90-degree position, to the minus, you know what I mean, the minus 2-degree position, so they're inside the wings and the body at that point. And you can see at that point, if one of the wheels hadn't cranked all the way in, this was, you know, very early 30s Russian engineering. They didn't have hydraulic systems to do this for you like you did in the Spitfires and, you know, other things. If one of the landing gear hadn't quite gone up, then we would see this spring on left or right side would show jammed. How do you feel about the size of that gauge, Stahl?
I like it.
I like it too. I like this plane. I know everyone's going to slag it off because it's not an F-18 Hornet, but it's perfect for me. Right, so let's start on the left now. We've got the peripheries done that I can think of. There's nothing else. There's no flap indicators outside or landing gear indicators outside. So we've got some knobs. Cap loves a good knob. So first of all, at the very back left.
You need flap indicators? Can't you just see it if you look at it?
No, you can't. You can't see them, and you do need them. Yes. We've got our flap handle on the next to the left bucket seat. By the way, this seat is horrendous. Imagine that. Me with my ME, I could sit in this for about 2 minutes and then I would literally die. We've got a flaps handle here, and you literally have to turn this. Let me try doing it now. Turn for about 10 minutes and the flaps will eventually come down. You've got the flaps level indicator just on the right of the weapons ordnance panel here, and you can see as you move the flaps up and down, the degrees of flaps down to 60 degrees and up to 0 degrees. And if you look outside, they are what I call the Spitfire type flaps, where they don't actually give you an extra lift, but they do increase your angle of attack. So it's that kind of weird flaps. You know, this plane doesn't need any extra lift. It's got more lift than you can ever need, but it changes your angle of attack. It helps you look over the front, and it's still, even with that, it's still very hard to see the runway. As you'll see later, it's pretty much impossible. Okay, so that's that. Next, we've got the we've got the fuel cutoff fire lever. Sorry, let me try that again.
Are you sure this doesn't give you any extra lift, because it's still directing airflow downwards?
I thought that. This is just what it says in the Spitfire, and it's the same type. So, internet, feel free to correct us, but I'm pretty sure it's purely an alpha correction, like the Spitfire, rather than thing. I reckon it will give you so much more. Let's not go into it, Shaw. Next, we've got the fire fuel cutoff valve. This here, push it in, and that is it open, so we can run the engine. It's a secondary fuel cutoff valve, basically. If there's a fire, pull it out, no fuel will get to the engine, and then we won't burn alive. Okay, that's that. Next is a supercharger lever. Now, not mentioned in the manual, so no one really knows how to use this. What we can see when we look at it is that we've got 1, 0, 2. So I would guess in its downward position 1, then 0, then 2, but I don't know. None of us actually know. Would you like to explain why you would use different supercharger levels, Stahl?
Well, it's basically just to get enough oxygen into the engine at different altitudes. So you generally engage higher supercharger levels at high altitudes. At least that's, you know, from the planes that I'm using, like that.
but we've got no actual instruction of how to use that, so that's going to be trial and error. Next, we've got our throttle. This guy here, the little brown one's a throttle. Move it up and down. I've got nothing really to say about that. It's a throttle. Next is our mixture lever, our fuel mixture lever. Now, again, not mentioned in the manual. We think forward. We're pretty sure forward is a rich mixture, so much more petrol per air element. And back we think is lean, less, possibly even to a full cutoff, less fuel per air, but we don't know the intervals, if you know what I mean. No one's quite sure, so we just think rich and lean. And all we've seen people using so far is fully rich when you want to start the engine, and you just leave it rich until you come to shut down, and then you pull it back to lean when you shut down. I stand to be corrected, obviously, but that's all we've figured out so far.
Lean you'd probably primarily use, if you either want to travel long distances, saving some fuel, or if you go into altitude.
That's interesting. Okay, well, it's something we're going to have to try out, obviously. I'd like to do a video on how to actually fly this thing, because there's nothing anywhere that tells you how to fly it at different altitudes and stuff, but I guess that will come a little bit later. RPM. So we've got an RPM here, RPM to minimum there, which is like 600 RPMs or something. RPM to maximum there, which is about, I've only flown this once, about just over 2,000 RPMs. Obviously, you can't go very high RPM. You got a massive cylinder, bore and stroke on this thing, so you're not going to get much past 2,300. I think it says roughly about the maximum, even on wartime emergency power. It says in the manual.
Can you feather this thing completely?
No, there's. It does say there's an augmentation switch, which is the one above, but actually it says on the cockpit wartime emergency power. So I don't see any feather ability. No, it's not a featherable screw. Look, go back to the. It doesn't look featherable, does it? That looks like a solid.
Up here.
That looks like a solid, non-adjustable propeller.
Oh, so this isn't.
So there is no feather.
Okay.
Okay, so that's RPMs. You're pretty much going to fly with the. Well, I don't want to say because I just don't know, but at least in dogfights, that's full or very nearly full. Okay. Next, we've got our wartime emergency powers, otherwise known as the augmentation lever in the what is kind of the flight manual. No one really knows, but we think forward is wartime emergency power on, which gives you a maximum RPM, 1100 horsepower, and a maximum use of 5 minutes before you have to come off. Now, we're not sure if this thing is kind of analog in that you can add different amounts of wartime emergency power, or if it's binary and you just turn it off and turn it on. Unless you've got anything to say on that, Charles, nothing else to say on that, I don't know.
I don't know how exactly the engine works here.
Roger. We're going to have to work that out on our flying video. Next, we're going to move on to the front dash. In fact, before we front dash, I've missed a couple here. If your left wing gun or your right wing gun jams, you've got a recharge. So, recharge isn't the right word. You know what I mean, though. You can charge the gun. Left gun, right gun. Everything on this aircraft is pulley cables, basically, which is perfect. Exactly how it should be. We've got rudder pedals down there, rudder right, rudder left, and we've got toe brakes, so we can toe brakes at the same time, or toe brake left, or toe brake right. It's the wrong way around, but you know what I mean. So we can do differential wheel braking on the ground if we want to. We've got the main control stick. On that, we've got the best looking trigger I've ever seen and prepare to fire. Whoops. That's pretty cool. No safety on the gun, obviously, because it's Russian. Who needs a safety? That button there, we think, is the weapon kind of bomb drop, rocket drop, but it's not clickable. Oh, it is clickable. Literally just fixed that. So that is for dropping your bombs and probably firing your rockets. Right, so firing your rockets, dropping your bombs, great. Next, let's go to the dash. Now, the first thing you'll notice when you get in this aircraft is that you are positioned right up high. At least that's my problem. So we can either go down in the bucket seat, whee, and that helps, and or we can press right control, right shift, and numpad 2, whee, and that puts us down. There's two ways of getting down there. Okay, so first of all, magnetos. Do you want no magnetos? Do you want magneto 1 isolated? Do you want magneto 2 isolated, or magnetos 1 and 2? And I don't know any reason why you would ever have not 1 and 2.
Maintenance maybe on the ground. Testing stuff.
There you go. Right, now, if we kind of go north from here at the top, we've got what I've never seen before is a clock heater. This is, and I'm not kidding, a heater for the clock. Why you would need that, I don't know, but you
A fair few aircraft actually have that. I mean, it's often included in like pitot heat switches and whatnot, but that's not that uncommon actually.
I've never seen a clock heater style.
I can show you several aircraft that have it.
Well, okay.
Made first and foremost.
And then we've got a clock there, and nothing else to say there, really. If we go down here, we've got the RPMs. It goes all the way up to 3,000. It says in the manual you shouldn't take it above, I think 2,300, 2,350 for short periods of time. So I'm not sure why it goes all the way up to 3,000. I'm guessing in a dive it could be forced higher, kind of like going down a hill in a gear in a car. It kind of gravity forces the RPM up. So I'm guessing it could be forced high, and then you could shag the engine basically. So that's that. Next is, now I may get in trouble because my brain's a bit muggy on this. We've got now, is it a variometer? It's 3 gauges in one, or is it a multi-gauge, or I can't remember.
It's not a variometer, I don't think that.
You don't think it's a variometer?
No, a variometer was basically just a climb rate indicator, wasn't it?
Yeah, okay. So this is something else.
It's multi-gauge, I don't know.
Okay, correct us, internet people. Right, anyway, outside we've got our oil temperature in degrees centigrade. Oh, blast, I forgot the maximum. It's about 85 degrees centigrade is the maximum that we want to have it. Now, that interests me because that's very low. Maybe it's, it's old 1930s oil. It's certainly in a modern car, you're going to run it up to 120 degrees, the oil, centigrade, it's no problem. So why we can only go up to 85 degrees, I find curious. My guess is old school oils, you just couldn't, get them as high temperature.
Maybe also oils that are more designed for cold temperatures so they don't freeze as high.
That's interesting, Roger. Nothing else to say on that, other than when we do the cold start, we have to make sure we don't rev it high until we got past 50 degrees, standard Warbird stuff there. We've got the oil pressure on the left. I can't tell you what units they are, so I'm not even going to guess, like kilograms per, I don't know, centimeters. I said I wouldn't guess, but I did.
Usually kilograms per square centimeter in Russian planes.
Roger. And then we've got the fuel pressure on the right there. Okay, probably same unit. Okay, next we're going to go up and right. We've got our speedo here. Pretty sure we've got indicated airspeed, kilometers per hour. Nothing to say there otherwise. The maximum she'll go is about 460 or in level flight here, but obviously in a dive you can take her to up to near 600, where you hit the structural limit at around 600. Next, above it, we've got our first switches. We've got battery on. We've got this one. Direct translation is shunt. In the manual, it says bypass. We've had a good think about this. We can't figure out what it is. Anyone know what shunt or bypass is? I think it's electrical generator, something like that. But
inverter, maybe?
Inverter. So let me know what you guys think. That's a bit beyond this. We've got a radio there. As far as I know, we don't have a working radio yet, but I'll investigate that further. Next, we have manual engine cutoff valve. So further down the line from the fire fuel valve is this, which is going to choke the engine. If you want to stop the engine, left click and pull, and it will choke the engine from fuel, and that's it. And then spring released, so it will shut down. Go back once you let go. Next, the main switch panel, and this is how you know when Cap's found the kind of aircraft he likes to fly. When that is the main switch panel. No DDIs here, no AMPCDs with 10,000 different options. You got 6 buttons, and half of them you don't even know what they do, but it doesn't matter. Perfect plane. Right, bottom left, let's start. We've got, if I can get that, go pitot heat, so obvious. Your nav light test, so you can press on. See your nav lights. Nav lights on and off. Okay. And this is caused some confusion. In the manual, it says that these buttons are something completely different to what they are. In the actual aircraft, they are fire left torch, fire right torch, and jettison all torches. Now, we've had a good think about this in GR. They don't do anything at the moment. They don't work, but they probably will do at some point. And I've spoken about it with Charlotte. The best we can come up with is signal flares. So we think signal flare left, saying, hostiles left or let's go left. Signal flare right, and jettison all signal flares. If you've got a better idea what that translation could be, any of this in Russian, we can't read Russian obviously. Well, that does literally say torch when we looked it up. So we think they're signal flares. Let us know what you think. Okay.
Yeah, I mean, it reads fuck hell, which literally is, torch.
Okay, next we've got our amp meter here. Now, interestingly, if you turn the battery and the bypass or the bypass on, the amp meter doesn't change. So here's my guess, Star. My guess is it's an amp meter reading from the alternator / generator, because it only goes on once you've turned the engine on. Would you agree with that?
Entirely likely.
Okay, there you go. So you can check your, it's like putting a multimeter on your car alternator. You make sure it's generating current. That's my guess. We've got our magnetic compass here. Now this is a thing because you've got a coarse cage knob here, which doesn't seem to actually do what it says. If you turn it left and right, you can see it basically adjusts your magnetic zero, your magnetic north. So is that what you would agree that is doing? It doesn't seem to be anything to do with the course, unless I'm grossly misunderstanding this.
Yeah, I mean, it's this coarse cage knob, so I take it, yeah.
So it literally is going to adjust our north for whatever reason, okay? That's a bit
beyond. You could probably get around things like magnetic declination and such with that.
Roger, I guess you'd zero it to a known compass or something. Right, okay. Okay. We've got our variometer here. I'm pretty sure I'm right in saying that in this case. It is a turn gauge and a slip gauge. So the turn gauge is left to right there, tells you whether you're turning, surprisingly. Slip gauge here, if you don't know what slip is, it's like angle of attack but in a lateral non-vertical plane.
Sorry, I have to interrupt you again, but a variometer is a climb gauge and not a slip gauge, not a turn gauge. It's a climb gauge.
But the whole idea of a variometer is it's more than one gauges at once, Star.
No, it's not. That's what we thought. That's what we got fucking ripped for. Okay, I'll quote you Wikipedia. A variometer, also known as a rate of climb and descent indicator, RCTI, rate of climb indicator, vertical speed indicator, VSI, or vertical velocity indicator, VVI, is one of the flight instruments in an aircraft used to inform the pilot of the rate of descent.
Oh shit! Really?
Yep.
So what
literally
the hell?
just a freaking climb gauge.
But didn't the guy on the internet say it was because it was multiple gauges in one?
No, that's what we thought.
Shit.
It's a fucking climb gauge.
Right, fine. Got to stop saying that. No more variometer. There's scratching from my memory.
Please do.
Oh dear, how embarrassing. Slip gauge there. Yeah, I told you whether you're slipping left or right with your rudder or whatnot. That's fine. Here you've got your weapons selection and armament panel. We can have, just looking here, we can have rockets. In fact, I'm not going to pretend to really understand this fully yet. Why don't we just cover it in the rockets and bombing video style, rather than talk about it now. Right, we're going to go directly right. We've got our flaps degrees indicator. We looked at that already. We're going to go up one. It is our VSI. We're not going to say variometer. It's our VSI, our vertical speed indicator. I'm pretty sure that's going to be meters per second, 5 meters per second, 10 up and down. Very useful tool once you've actually learned to fly your aeroplane correctly, which I'm just about after 3 years learning to do. Next, if we go up, we've got our barometric altimeter. We've got 2 needles in there. We've got the long one, which is going to be the hundreds of meters, so 100 meters, 200 meters, 300 meters, and so on. And the big one for kilometers, 1 kilometer, 2 kilometer, 3 kilometer, ASL. And we can set our QFE here in millimeters mercury. So you can set your 0 basically for the runway. That's that. Up, we've got a rheostat for the gun sight, which is pretty obvious. It is how bright you want your gun sight. Can't see it here, obviously, but there you go. We've got your starter. This is the bane of everyone's life who's bought this plane. You pull it out to charge the starter motor, is the best thing I can say. Ah, look, when you pull it out, the ammeter goes down. How interesting. That is definitely charging a massive capacitor for the starter motor. I'm pretty sure it's something along those lines. How that does it with a flywheel or charging a kinetic flywheel, maybe that's what that's doing. Again, there's nothing in the manual about this. This is all stuff we've had to work out and guess. That is charging your starter. Whether it's kinetic or electric, we're not entirely sure. You have to hold it for exactly 15 seconds. Oh, but crap, it says 8 seconds in the manual. Yeah, that doesn't work. 15 seconds out, and then to start the bird, you push it in to translate that either kinetic or that electric energy into motion of the prop. Okay? And it's really hard to use. Next, we've got... this is a confusing one. Let's consult the manual. We've got our... It says a CHT indicator. It's very specific in the user manual. It says a CHT indicator. What's a CHT indicator? No one knows. it's not a thing in kind of Western terminology. As far as I'm aware, I've not found it. I'm pretty sure it means an EGT. And send.
Cylinder head temperature gauge.
Really?
Yeah, Wikipedia. Cylinder head temperature gauge, CHT, measures the cylinder head temperature of an engine.
Okay, well...
Only used on air-cooled engines. The
okay,
head temperature gauge just...
Okay, so I'm going to go with you. Now let me have my complaint then. In the user manual, quote unquote, it says it's a cylinder head temperature, okay? But in the user manual, it also says when you're looking through the parts that say how hot you're allowed to run this thing, it talks about EGT. It says EGT. It says do not exceed this EGT, do not exceed that EGT, and refers to this gauge. So it calls it EGT. So it's calling it a cylinder head temperature in one place, and it's calling it an EGT at well, which is right? Are we just going to assume EGT is the same as the cylinder head temperature? Well, we have to really, because otherwise we can't fly the bloody thing. For instance, it says EGT must not exceed 235. We look at the gauge here; it has a red mark at 235. I think we're fairly safe in saying, don't blame me, blame the manual, that the EGT, as it refers to, is the cylinder head temperature. Why don't we just, between friends, why don't we just call it the engine temperature, Charles?
Well, I mean, if you quickly want me to look up what the Russian writing on it means, I can do that. Yeah,
you're going to get that done. So this, for now, it's our temperature. Obviously, you don't want to be below 100 there because you're in a world of pain.
Oh, by the way, the thing in the center of the gauge it says EMP cylindra, so that's definitely cylinders.
Okay, fine. Okay. So needless to say, we don't want to be below 100 degrees centigrade because combustion simply can't work. If your car engine is not up to 80 degrees or whatever it is, coolant temperature, the combustion just doesn't work properly. You have to run rich for it to work. So same here. And you don't want to go too high, or otherwise you'll melt your probably aluminium cylinders, I imagine they are.
I think so. Wouldn't that be stupid?
What do you mean, wouldn't that be stupid? What do you mean, Star?
Aluminium cylinders? Isn't there more durable stuff to use that's probably cheaper as well?
So the reason why my car and your car has a cylinder head in it is not because it's weak, and it is weak. It is very weak, but we have cylinder heads because it can shed heat energy very well because it's much less dense than steel, and it keeps the valve seats cool. That's why we have aluminum cylinder heads, and that's why I'm going to guess. Let's go and have a look at the front here. I'm going to guess that these are aluminum. As ever, I stand to be corrected, and maybe these guys didn't have aluminium in 1930s, but to shed heat, which is what the air-cooled engine has to do, then it wants the less dense material possible. You can see the push rods in there as well. So that is going to be my input into that. I stand to be corrected as ever. Anyway, if you get too hot, then obviously you get too much combustion. You get what you call pre-combustion, and the thing will knock itself to bits, literally your engine detonation and knock. I used to do this for a living. Didn't make a very good living. Right, below that, fuel gauge style. Fuel gauge. Now, I'm going to guess, I'm not even going to guess, it says times 10 kilos. That's what it says, isn't it?
Yes.
Well, that's not... Oh, yes, it is right. Sorry, up to 150 kilos of gasoline or whatever the thing ran on. Okay, it makes complete sense. Roger. Next, we've got our cockpit light rheostat, and it's actually a good cockpit light in this. It's nothing to say about it. It's a good cockpit light. Next, I forgot to talk to you about Charles. I forgot to prepare for you for this one. You're going to like this. Are you ready? There are two priming things on this. There's a priming pump on the right, which says a start pump. Okay. You just, you pull it like you do. It's bugged. Oh, God, I get in trouble for saying it's bugged. It's not working as the manual says. Oh, I can't even say that nowadays, can I? It's hard to use. There you go. I can say that. So the pump, that builds up the pressure in the fuel line, okay? And then the bottom switch, which says primary fuel switch, is the primer. Okay, so what you do, Style, is it's not primary if it's in the upper position. You move, once you built up fuel pressure with a pumping handle, you move the switch to the left. That primes the, quote, bottom of the engine, as the best I can translate that Russian. You do 2 to 3 seconds to build up fuel pressure into the bottom of the engine. Then you put it into down position for 2 to 3 seconds, and you move it to the motor position, which we believe means cylinder head, and that primes the cylinder head with fuel. Don't do it too much or you'll flood it. And then back to the neutral off position at the top, and that is your engine primed. Now, is it because it's a radial that you have to separately prime the two different parts of the engine? Maybe. I don't know. Never touched a radial before. Any input in that style?
I have no idea, honestly. You probably know more about engines than I do.
Okay, guys, who are out there who've worked with rotaries. What are these? Inline bloody
Radial
engines. Why could we have that? I can't quite. There must be something that's different to a normal inline straight engine or V engine. Here's the pump. You turn it clockwise, and then you pumpty. That's going to prime, pressure into your fuel, and then lock it. Next, you've got your engine and oil radiator cooling cowls. So this one here is the main engine cowls. If you look at the front, open and close it. Front, close. So it's not cooling the engine. I mean, this doesn't have a liquid cooling system. It has an air cooling system. It's one of the problems with these engines. Although they're durable, they do cause massive drag, obviously, because of the geometry of that. So if I want to cool the engine down, if my oil is getting too high, if my cylinder head's getting too high, do that. Actually, let me take that back. That's only if the cylinder head's getting too high. Down here, the next knob is the oil radiator cowl. If the oil is going to have a air to, presumably an oil to air cooler, and if your oil's getting too high, then you're going to feather that or put that fully open or closed for that. Okay, Charlington. Next, we're going to move on to the oxygen equipment. Now, I can't get this to work, and I accept I may very well be doing something wrong. So, to isolate the system, to turn it on and off, is what they call the oxygen shutoff valve. To open it, turn it anti-clockwise as per the manual. Next, we've got what we call the manometer. In fact, it says manometer on it. No one's sure what a manometer is.
Yes, it's a pressure indicator.
It's a pressure indicator. Since when has the word manometer ever existed?
It is. It actually does in German. Pressure indicator in German is a manometer.
Oh, I mean, I've been fine. It's obviously a pressure indicator. It says kilos per centimeter squared, but I just couldn't work out what they called a manometer. Okay, we now know manometer means pressure indicator. Very good. Okay, so that's that. On the right of that, we've got our flow meter. Okay, now I don't know what units is this going to be in, but it's, you want to have oxygen flow, so that needle wants to not be at the bottom like it is now. Okay, so it says in the manual to compare the manometer reading to the actual aircraft altitude, and if it doesn't match, then we have to adjust it with what they call, and get ready for this, it says the oxygen adjusting valve, but I quote, the aneroid capsule hand wheel from the manual. So we have to adjust the aneroid capsule hand wheel here to match the manometer with the ambient altitude. Problem one is that the aneroid capsule does not actually, capsule hand wheel doesn't seem to do anything. Whatever I change, this doesn't change. So probably the answer is it's just not modelled in DCS at all, and maybe never will be, I don't know. Or my misunderstanding is just completely wrong.
It might be phrased badly because there's another handle at the bottom that actually does change the right gauge. It's the emergency oxygen.
And I quote, if aneroid capsule hand wheel no function, then use emergency. So only if the aneroid doesn't work, we use the emergency.
Well, it doesn't work, so use the emergency.
I know, this is what I did in my startup video. I said, okay, this doesn't work, use the emergency and put it to number 8. The reason I've said number 8 is because it's in the middle and it seems safe. Obviously, it's not a pressurized cockpit, so we need that to stay alive. That's the oxygen equipment as best I can use it. Anything you want to add to that, Stan?
Nope. If you find yourself above 8 kilometers on this thing, then you're probably doing something wrong or very weird.
You're meant to turn this system on if you go above 4,000 meters. Right, next, there's a handle down here for adjusting the seat height. Prepare your face for the most expansive, complicated, easy to get wrong, easy to break and I'm not even kidding, they equipped I-16 real pilots with wire cutters, real big shearing, fence cutting wire cutters, in case they cocked this bit up and the gear got jammed. If you put some slack in that cable, one of those cables, the gear would jam, so you could snip one of these cables to release the landing gear. That's Russian ingenuity. Just like my car, I have to carry a spanner around in it to get it to work. They had to do this. So prepare your face for stun. Okay. First of all, the easy bit. This main turny handle is the gear handle. You have to turn that no less than 100 times manually with your hand to raise and lower the landing gear. Next, we have a ratchet mechanism to change the direction of that turn. Now, I haven't fully understood this yet, But if you got do what they call gear direction, again in the manual it says something completely different, but you got up and down, and you can see it interlocking with the ratchet wheel of the handle there. You can just about see that in there. Okay, so we're locking the ratchet there, so we can go one way or t'other. So one way you turn the handle and it will go gear up, and when you put the gear down, I can't remember if it's up or down now, but you turn it the other way, the ratchet works the other way then, and then the gear will go down. Okay. As well as that, we have the, and I quote, emergency gear brake lock from the manual, or just probably I'll call it brake lock here, or a gear lock. So once your gear are only in the down position, or like on the runway here, then you pull it, engage it, which is to pull it towards you. If the gear are anything other than straight down in this position here, you unlock it. And let's just see what happens if I unlock it on the ground. Nothing. But that unlocks the gear so they can travel from the downward position. And finally, we have the one that no one understands at all, the brake gear spring handle. Every time you want to turn this ratchet handle, you have to do something with this. No one's managed to figure out exactly what this does with the mechanism. If you know, let me know, please. And that star, buddy,
where is that thing?
It's sort of, you're very, 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 very right. Like, head right back. Gear brakes. Can't even say it now.
Oh, there.
And it's again in the manual it says something completely different, but no one really sure what that is. Maybe put some tension on the wire, something like that. Because the critical thing from history is that if you put slack in these wires, which would be really easy to do, you are screwed. They'll come off the pulley, and that's you done. So I reckon it's something to do with slacking, doing something to do with a spring to take up the slack on those lines. That's the best I can think of. Okay, so in all of the other warbirds, you would just have a button or something, literally a button that would raise your lower landing gear, and it would do all of these things hydraulically controlled by early electronic switches, I'd imagine. Maybe not electronic switches, whatever was prehistoric to early electronic binary switches. Analog switches, I guess. And yeah, but you have to do it all yourself, and it's actually extremely satisfying just to do a mission when you actually got your landing gear up. Just doing that is cool. Okay, and that's it. I know we made a real meat of that, but we like talking about little bits of history as well as just saying it's ammeter, it's rheostat. It's just fun. It's a cockpit tutorial. Anything you want to add to that? Super style.
Negative. First time sitting in it, and I'll love it to bits already.
I love it to bits already. I'm going to fly the out of this thing. Right, I hope you enjoyed that, guys. We're going to learn to fly the thing now. See you later.